Welcome to Pre-Algebra with Miss Betsy. Today in our class we're going to be talking about triangles. We're going to identify specific types of triangles, and we're going to see that you can compute the measure of an angle in a triangle if you're given a couple of other pieces of important information. Before we get started though, our lame joke for today is a very quick one, and I wonder if you can tell me what Moby Dick's favorite dinner was. Fish and chips. So, you see that I have drawn some triangles up here on the board. And there's a very specific definition of triangle that we want to use, and I've gone ahead and taken this equilateral triangle over here, which I'll define equilateral in a moment. But I've identified some endpoints, some points on this. We have the point X, point Y, and the point Z. And we see that in our text. By the way, I'm using Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. I'm using the first edition. I'm in section 11.5 on page 365. And it tells us that a triangle is a figure in a plane that has 3 sides, 3 vertices, and 3 angles. And the sides and the angles and the vertices can be very clearly labeled. In case you don't know vertices, that's the plural of vertex. So you have one vertex, which is the point at which the 2 rays go out from either side to define an angle. So you have one vertex, you have 2 or more vertices. It's not vertices, it's vertices. So if we have our equilateral triangle here, there are going to be 3 angles. And remember, we can identify those angles by just the letter, the point at the end, or by naming the angle itself. I'm just going to call these 3 angles, and they are angle X, angle Y, and just for grids, I'm going to call this one angle XZY. Now, why did I label it that way? I called it angle XZY so that you would remember that you can identify angles in one of 2 ways. By the angle symbol with the point of the vertex, angle X, angle Y, or identifying the 3 points with the point at the vertex being in the center. So there are 3 angles in the triangle. There are also 3 sides that make up a triangle, and the sides are line segments. You remember, a line segment has a specific beginning and a specific ending. So you have line segment X, Y. With that straight line on the top, there are no arrows because this means that we have a specific beginning and a specific end. We have line segment XY, line segment YZ. And remember that we're using capital letters only. You may not use lowercase letters when you're naming and describing geometric figures. And then we have line segment XZ. Could I call it line segment ZX? Sure. But our minds tend to like to put things in alphabetical order or in numerical order. So we have 3 angles, and we have 3 sides, and then we also have 3 vertices, or 3 vertexes. The vertex is X, the vertex is Y, the vertex is Z. So we have 3 vertices, not 3 vertexes. 3 vertices, and those you indicate simply by the capital letter that indicates that point. It's vertex. The vertex is identified as X, Y, and Z. So there are 3 vertices, 3 angles, and 3 sides. And a triangle, and of course if you go back at all to Latin or just general knowledge, tri is 3, a tricycle, an angle. So a triangle is a geometric shape that consists of 3 angles. And the only way you can get 3 angles is if you have 3 sides where they're meeting together. Okay? Remember what I've been saying, vocab, 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 more vocab today. There are some specific types of triangles that we're going to define for you. One of those triangles is called a scalene triangle. And I can't show you exactly for certain, but what you see here, or what you are supposed to see here, is that these 3 sides have different lengths. And you're thinking, what in the world are you doing here? Well, when you're dealing with triangles and drawing pictures of them, you use these hash marks to indicate which sides have the same length. And in a scalene triangle, none of those sides have the same length. So you have 1 hash mark, 2, and then 3. That's what a scalene triangle is. All 3 sides have differing lengths. Now, we have an isosceles triangle, and this has 2 sides that have the same length. 2 opposite sides have the same length. This 3rd side here is different, and this sort of looks like a cheerleader's megaphone or the classic dunce cap that you see pictures of from years ago. This is pronounced isosceles. This is pronounced scalene. Isosceles. Okay, isosceles triangle. Now what would you think an equilateral triangle might be? We have no sides here that are the same. 2 sides that are the same. Equidistant, equal, lateral length, equal length sides in an equilateral triangle. All 3 sides of an equilateral triangle are exactly the same length. Scalene, no sides are the same. Isosceles, 2 lengths are the same. Equilateral triangle, 3 lengths are the same. Now we also see that we can classify triangles based on the size of the angles. Now remember, just a couple of lessons ago we talked about acute angles. They're cute little angles. Acute angles all are less than all are less than 90 degrees. So we have 45 degrees, 60 degrees, 75 degrees. All 3 of the angles in an acute triangle have to be less than 90 degrees. All angles are less than 90 degrees. Well, what's a right angle? This is a right triangle because we have this little square here, indicates that this is a right triangle with a right angle. A right angle is a 90-degree angle. So a right triangle has one angle is 90 degrees. Now, this funny looking triangle, typically if we just tell a child or an adult to sketch a triangle, you're going to either sketch something that looks like a right triangle or you're going to sketch an acute triangle. We don't tend to make our triangles out like this. But this is what they call an obtuse triangle. And you'll remember that when we talked about obtuse angles, an obtuse angle is an angle that is greater than 90 degrees. So an obtuse triangle then has one angle that is greater than 90 degrees. So we have 130 degrees, 20 and 50, and 20 and 30 degrees. Now let's do this exercise right here. 45 degrees plus 60 degrees plus 75 degrees. We're going to add up the measures of the three angles. 45 and 60 is 105, plus 75 is 180 degrees, is the total measure of the angles in this acute triangle here. Now let's go over here to our right triangle. In a right triangle, one of those angle measurements is always going to be 90 degrees. And in this one, then we have randomly defined measurements of 40 degrees and 50 degrees. 90 plus 90 is 180 degrees. Are we seeing a pattern here? With an obtuse triangle, one of those angles has to be greater than 90 degrees. So we have 130 degrees in this one, plus 30 degrees, plus 20 degrees. 130 plus 30 is 160. Plus 20 degrees gives us 180 degrees again. So what you see is that the sum of the measures of the angles of a triangle always equals 180 degrees. Let's see. I'm out of room on my board. The sum of the measures of the angles in a triangle always, always, always and forever never will change. The sum of the measure of the three angles in a triangle is always 180 degrees. And what does that tell us then about right triangles? Can you ever have two right angles? No. If you have two right angles, 90 degrees and 90 degrees, that's 180 degrees, and you can't have any measure for the third angle. So you cannot have two right angles. Similarly, you cannot have two obtuse angles. Because if you have an obtuse angle that is greater than 130, greater than 90, you can't have another one that's greater than 90 because it'll be too many. It'll be more than 180 degrees. Similarly, you can't have an obtuse right triangle because obtuse has to be greater than 90. Right is equal to 90. You add those together, your measure is going to be more than 180 degrees. So I'm sorry, vocabulary, vocabulary, vocabulary. So let's go ahead and turn on to page 366 now. And in this, they're asking us to classify three different pictures of triangles based on two things. First, based on their angles, and then second, based on the lengths of their sides. So let me do my best to sketch these three triangles here. And they're not going to exactly match your book, but they'll be close enough. So this is triangle A, B, C, and you use the triangle shape and the three vertices to identify a triangle. And you have side A, B, side AC, and side BC. And then you have this triangle here, which clearly is not drawn as a right triangle, because I can't draw that well. Even with a ruler, I can't draw that well. But because I have this little square in here, this tells me that this is a right angle there. And I have this side and this side. Oh, interesting. Let me sketch this a little bit better. Okay. And then we have this triangle right here. Let me go ahead and write the names. We have D, E, F, and we have G, H, I. So we have three triangles that are sketched here, and our instructions tell us classify triangle ABC, triangle EDF. Let me see. You know, EDF would be fine. It makes sense to do alphabetical, doesn't it? Triangle DEF and triangle GHI according to the length of their sides and the measures of their angles. Now, scalene, isosceles, and right. Scalene triangles, none of the sides are the same. So this is a scalene triangle, isn't it? 1, 2, and 3 hash marks. So this is scalene. What about this one? We look at these hash marks here, 1 hash mark, 2. So what does that tell us? It tells us that line segment ED and line segment DF, those two lengths, those two sides of the triangle are the same. So that means that triangle DEF is an isosceles triangle. Remember, that's pronounced isosceles. And you're seeing a pattern here, but you still have to verify 1, 1, and 1. Our sketch tells us that these 3 sides are equal. So of course triangle GHI is going to be equilateral. Equilateral. Now, according to the angles, what do we see here? Let me do a little bit of a hint here. That looks like a right angle, doesn't it? This angle is greater than 90 degrees. So if an angle is greater than 90 degrees, what's that called? It's an obtuse angle. So this triangle is obtuse because it has an obtuse angle. Now, what can we say here? This is a right triangle. It's a right isosceles triangle. So it's a right isosceles triangle because it has a right angle in it. I want to make sure that I don't misspeak. Okay. Because we have all of the sides are the same, all of the angles have to be the same here. They're all going to be less than 90 degrees. So all equilateral triangles, by definition, have to be acute, meaning that the measure of their 3 angles is identical, and all of those measures have to be less than 90 degrees, and actually by definition they're going to end up being 60 degrees would be the measure of all of the angles in an equilateral triangle. However, our first triangle here, triangle ABC, it's scalene because none of the sides are the same. It's obtuse because it has a large angle in it. Triangle DEF is a right isosceles triangle because we have our corner here, our square corner illustrated, shown to us to be a 90-degree angle. 2 sides are the same, so it's isosceles and it's a right triangle. Finally, we have an acute equilateral triangle because the sides and the angles are equal. Now, there's one more piece of information. It's very interesting. If you were to cut the corners, the 3 corners off of any triangle and line those 3 angles up, it would always give you a straight line, give you a 180-degree angle, and what they're telling you what they're showing you in this chapter is what I said in this section, is what I said at the beginning of the lecture, where the sum of the measures of the angles of a triangle is always equal to 180 degrees. The sum of the measures in degrees, measures of the 3 angles. I would hope that you would know that a triangle has 3 angles and that we're adding all 3 of them together. The sum of the measures of the 3 angles of a triangle is always and forever 180 degrees. That is an essential piece of information for you to have. So let's go ahead and look at this example here on page 366. Make sure that you can identify and sketch all of these types of triangles. Our question here says, write and solve an equation to find the measure of angle x. So in your book, you have a scalene triangle that has been sketched. And you have vertex of y, vertex of x, and a vertex of z. And the measure of angle y is 116 degrees. And the measure of angle z is 22 degrees. Find the measure of angle x. So what sort of an equation could you write? Well, the measure of angle x plus, do I want to actually go ahead and show you from the very beginning, the measure of angle y plus the measure of angle z is equal to 180 degrees. That's the true statement that you know. When you have a triangle, you add the measures, the sum of the measures of their angles is always equal to 180 degrees. We want to find out what the measure of angle x is. Measure of angle x plus 116 degrees for angle y plus 22 degrees for angle z is equal to 180 degrees. Now it's just simple basic pre-algebra. The measure of angle x plus 138 degrees is equal to 180 degrees. When we do our subtraction, subtract 138 from both sides of the equation, we have that the measure of angle x is equal to 42 degrees. And that's all that you need to do to be able to calculate the measures of, to compute the measure of an angle of a triangle if you're given two other pieces of information. That's all we have for section 11.5, and I'll see you next time.